The mass is given as 5 kilograms. The starting velocity is given as 30 meters per second north. The final velocity is given as 40 meters per second west. So the thing to notice is that these two directions are not in a straight line. We're going to have to do some work with components, some vector addition here. The time is 10 seconds. So some kind of a net force was applied on the object for 10 seconds. That will impart an impulse onto the object, which will change its momentum. And we'll use the impulse momentum theorem, not Newton's laws. I mean, we can solve this just with Newton's laws, but we want to practice using the impulse momentum theorem. We also want to practice vector addition. So let's see how this works. We'll have the change in momentum will equal the net impulse. That's the impulse momentum theorem. The change in momentum is P2 minus P1. The net impulse is the net force multiplied by time. Impulse is force times time. We can solve for the net force by dividing both sides by time. I'll also change momentum to mv. So we have to find that expression. Now, what I'll do is I will calculate each of the two terms first with the directions in it. So the first term is mass 5 kilograms times 40 meters per second west. Okay, I'm going to throw in the west there just to be clear. That's in the west direction. Divided by 10 seconds. Minus the second term, 5 kilograms times 30 meters per second north. I'll make sure I add the north in there to be clear on the direction. Divided by 10 seconds. Calculating those individually, the first term is 20 newtons west. Minus the second term will be 15 newtons north. This is vector subtraction. The answer is not 5. Let's be clear on that. The answer is not 5 because one's going west and the other's going north. Vector subtraction can always be changed into vector addition by flipping the direction when you flip the sign. So I change the minus to a plus, then that'll flip the north direction into the south direction. So now I have vector addition, 30 newtons west plus 15 newtons south. So with that, I will draw a triangle out of it. Let's make that a bit more horizontal if I can. That's 20 newtons west, followed by 15 newtons south. We go tip to tail. And what I'm looking for is the hypotenuse there. That's going to be my net force. I'll find the hypotenuse. I'll find the angle as well. The hypotenuse can be found, so the magnitude will be found with the Pythagorean theorem, 15 squared plus 20 squared all square rooted, which will equal to a nice 25 newtons. And the angle will be found by inverse tangent of opposite over adjacent. And I should know this angle by now. It shows up so often, probably 37 degrees. Let's take a look. inverse tangent 15 over 20. Yeah, it's 37 degrees. Okay, so my final answer, I can say my net force is 25 newtons west, 37 degrees south. And that was done using the impulse momentum theorem. Could have used dynamics, we would end up with the same thing. With dynamics, what happens is that with dynamics, I would use my V1, I would use my V2, I'd use my time. I'd find the acceleration. And after I know the acceleration, I can do F net equals ma. But to find the acceleration and use the kinematics formula, okay, so then the net force would be mass times that, which would be mass times V2 minus mass times V1 over delta T. So you'll find that we have the exact same formula as we did using the impulse momentum theorem. There really is no difference. We are just, it's just different names of terms. Sometimes the formula gets easier if you use one method versus the other method, but there really is no new physics here.